Hello, this is video number 23, and we're still in binary search trees. We're going to be in that for a little while. The common use of a BST, binary search tree, actually for any container, but it really takes on a new life with binary search tree. It's called a dictionary, D-I-C-T-I-O-N-A-R-Y, an abstract data type. Back in the day, I'm used to this being called a table. So I'm going to put also known as table, T-A-B-L-E. It's an abstract data type where you look stuff up. And that's how I'll define the ADT. Abstract data type for this, really only two operations, like the stack and the queue, push and pop, insert and remove. The ADT for a dictionary operation, Roman numeral number 1, the put operation. Put a value, V-A-L-U-E, in the dictionary. Roman numeral 2. I'll put in a box. There. Now it's an official operation of the abstract data type. How about get? Get a value from the dictionary. Well, how vanilla can you get? You put something in, you get something out, except the get operation has a twist and a comma at the end of that line. Get a value from the dictionary given a key. A key. A key is a tiny little thing you use to go retrieve something. You send the key in there, send the key into your dictionary, and get it. If you think about what a dictionary really is, so to speak, those big, thick books in the library, you could think of the key as the word you're trying to look up. You look that up in the dictionary, and the value is the definitions. And if it's a common word, there could be pages of definitions. Who knows? So if I wanted to do a picture to illustrate these things, here is a fig to go with that abstract data type. Let's look up value. The value is the big thing. I haven't been multicolor in a while. I think I'll try that if I can get away with it. The value is the big ponderous thing. All the information, complete student record. So this is big data. Well, big data, that means something else. Big data value. Big data item. There. Now it fits with the terms we've been using so far. The value is the big data item, and the key is just a little sliver. It's hardly anything. Maybe in blue. Here's the key. Little data value. Needs to be a little larger than that, or I don't have room to write it. No, I'm going to call it a little data key. There. I'm making up terms and definitions as I go along. Big data item, the little data key. Now that could be a field in value. It doesn't have to be. In our case it is. If you've looked over the scary looking code for the MP3 data type that's in the source code files that I emailed you. The key is the code. It's just a little number, plain old integer. And the value is all this information about MP3s. Actually, it could have been a whole bunch more stuff. It could have been more than just the artist and the year of release. It could have been the lyrics of the song. It could have been the record company, all this other stuff. So anything we want to know about the value that we put in the dictionary will go in this big data item, a one-stop shop for everything we need to know about that one particular thing. How do we find it? Well, we send in a little search key. Now then, now that you got these pictures firmly in mind, I'm going to have to erase them because I want to illustrate the put and the get operations using these things. What have I got here? A green value and a blue key. Okay, mental note. So here's a fig to go with that. How does the put operate? Well, to be able to put this thing in the dictionary, you have to provide the whole shebang, the whole enchilada. I think that was green. So we put that entire large value type item in there. I'll just say value. I'm afraid the word value might get overloaded in this discussion. But in this particular context, value means something specific. It's the entire package of data that we're inserting into our dictionary. And I know I haven't said anything about binary search tree. That's for later on. This is just a description of what the values and the keys are. Now, on the other hand, the companion operation, Roman numeral 2, after you've got stuff in your dictionary, you look stuff up. And that's a get operation. Get. And I'm also going to give it giant parentheses, but for a different reason. The key that we're sending in to search for this, we're looking for a particular definition of a word, pizza. Let's look up pizza. So we put in everything we possibly wanted to know about pizza into our dictionary, whatever that may be, maybe even some images and recipes and stuff, who knows? It's a gigantic package deal. Over here, maybe you just search for the word pizza. That tiny little thing that you send in to retrieve that record is called the key. So you send in a key as one of two parameters to the get operation. The other one is a blank to be filled in, comma, and that'll be one of my dotted boxes, a big dotted box representing reference to a value variable. Now, you don't have to think about that real hard to understand why things work that way. We dump all this massive database into our container, the dictionary, also known as the table. All of that is put operations, and this might be done, we might front load this by reading in some gigantic file of values so that we've already got a populated internal database in our dictionary so we can just look things up. How do we look things up? Well, we got to know the key. We send in the key, and if it finds it in our dictionary, which we're going to implement as a binary search tree, if it finds what a value type item that matches this key anywhere in the container, I keep confusing the issue, I'm sorry. Forget about binary search trees for now. I'm just talking about dictionaries, values, and keys. Okay, we send in a little key. Oh, can you find me anything about pizza in there? And if the answer is yes, if it is in the dictionary, then it fills in this gigantic reference parameter with whatever value was previously inserted with a put operation. Now, why doesn't it just return the value? Well, that's an insult to your intelligence at this point, isn't it? It's possible that what we try to send in there, it's possible that key doesn't match any values that are currently stored in the dictionary. In which case, it's good to have the option of returning true or false to indicate success or failure to whoever tried to do this lookup operation. Same thing over here. Put. Why would this need to be true or false? To either put something in or not put something in. Well, we don't allow, now listen to this carefully, we don't allow values with two of the, listen to me carefully stumble over that. We don't allow two values that have the same key. So if someone's already inserted all this information about pizzas, you can insert maybe pizza style 2 or something, or deep dish pizza or whatever, but you can't insert another value that has the same key. So it's not going to actually check and see if the two values are equal to each other. It makes sure that that key is not already present in the dictionary, because we can't do that. I mean, every key, in other words, every key has to be unique that's inserted. That's where we will disallow duplicates. What else is there to say about those? If you comprehend all this picture, then you know what? That's a pretty compact little discussion of what are called key value pairs. They actually have their own acronym. I guess it would be what? KVP? I bet you could search for KVP on Google and it would give you all this information about key value pairs. But I'm going to put that down here as almost a closing afterthought. Key-value pairs. And a lot of modern database strategies are based around this. You insert key value pairs. You dump in a key and a value where it's possible but not necessary that the key is actually one of the fields in your larger value data type. But what's distinct here is you send in the values and then you retrieve them with keys. And now that I've repeated myself 5 or 6 times, I think I'm going to have another cup of coffee and let that be, and we'll go on to the next thing. I'll see you online.